All right, we'll just go over this stuff. Now let's see, I'm not going to be here on Friday, so I'm going to cancel class. Okay, so for starters, there's no class this coming Friday, which is October 20th. So that's one thing that I just want to mention. All right, so okay, so that's one thing. Now, what we've got coming up on Monday, and I guess that would be the 23rd, is our first test. I've already emailed out that information, or messaged it out, I guess I should say. So, so you should start getting ready for that. And there's a review that's available in Moodle down in the test downloads, so you could go there and get the review. So why don't you open that up and we'll go through the review just here briefly. We'll cover it in detail if anybody needs on tomorrow, Thursday. So no class Friday, the 20th, and exam 1 is Monday, the 23rd. And generally speaking, for those of you who are online students, that'll be from 6 to 6:50, and in-class students, it's from 1 to 1:50. All right, so that's a little bit of what's going on there. Now, our review here has a list of things that will be on that, or could be covered on the test, might be the best way to say it there. So we started off with 2D force components and resultants, so using sine and cosine to break forces up, and then theorem of Pythagoras to find the resultant, and using the arctan to get the angle of the resultant right there. Then we did some stuff with 3D forces and vectors, using the angles to find a unit vector, and then finding the force vector right there. And then we did double projections, where we had 2 angles that reference the force to one of the axes as opposed to just one. We had a homework problem on that. And then we went through position vectors, where you can find a unit vector, or I guess you start off with a position vector. RAB is RB minus RA, and then find the unit vector for that, and then scale it up by a force magnitude to find a force vector. Then we did dot products. AB cosine theta is equal to A dotted with B. What that is used to do for us is to find the projection of a force onto a given line, which would be tension or compression. Then we did 2D particle equilibrium. Sum of Fx is 0, sum of Fy is 0, and then we handled these special force cases, cables, pulleys, and springs. Then we did 3D particle equilibrium, where we used more of a vector approach, found a vector expression for each force, put those forces in columns, and then used the rows as equations. Each row is x, y, and z, and you can then set the sum of the x, y, and z rows to 0 and solve. Then we did 2D moments with force times distance with d perpendicular to f, and 3D moments generally found using a cross product. And then to find a moment about an axis, you dot the moment vector with a unit vector for the axis. So that's the stuff we've covered. We also covered some vocabulary, so you should know these terms if you find them in the problems. Vector and scalar, a scalar has only magnitude, a vector has magnitude and direction. Add 2 or more vectors together, you get a resultant. Scalar and magnitude are pretty much the same thing. Then we've got projection, projection along, projection parallel to, tension and compression, and component parallel to. These are all pretty much using a dot product in 3D to find the projection of a force along a line, which would either be tension or compression. And we've got projection perpendicular to and shear and component perpendicular to. those are all shear is what they are, which is perpendicular to the projection along. Okay, so use a dot product to find the projection along, which would be tension or compression, and you can use some vector subtraction actually to get the shear, or you can use the theorem of Pythagoras. Okay, we did components, which is a part of a vector, Cartesian vector, which is x, y, and z, angle with the x, y, or z axis, which would be alpha, beta, and gamma, equilibrium, which is sum of f equals 0, and then moment about a point and moment about an axis. So you should know what those terms are and how to use them. Okay, I have some example problems uploaded too. So here's just a basic force vector with 3 angles, and then you just use the angles to find the force vector. Here we have a double projection there, so that's one you might practice on. Okay, here we have a force vector from A to B. So you'll need that position vector from A to B, the unit vector from A to B, and then scale it up by a magnitude of 8,400 newtons. Okay, we need a few other vectors here, RAC, RCA, UAC, and UCA. Okay, on this particular test, which is where these problems come from, what I did, I had kind of the first page where people had to find the vectors. And once they had them on the second page, they started to use them. So here I have them to use the answers to the previous problems to find the compression in AC. So that's a dot product. And then to find the moment of FAB about point C, that's a cross product. Here's another one, finding the resultant of F1 and FAB. And then here's a 2D equilibrium problem. Okay. So that's just some example problems that I uploaded. You know, be sure you study everything. Don't just study the example problems. They're just an indication of what the test might look like. So, you know, that's just some ideas of what previous problems have looked like. So that will get you prepared for what you're going to be doing on the test on Monday. Now, things that'll definitely be on the test is I'll definitely have you find a force vector. I'll definitely have you do a projection, which is a dot product. And I'll definitely have you do a 3D moment, which is a cross product. So be prepared to do those things. And as I was telling the people in class, get it figured out over the weekend. Just understand what those processes are step by step so you can execute them on the test, you know, and do them on the test, I guess might be an easier way to say that. You know, you don't want to be trying to figure out how to do it on the test. You just want to get right into it and do those things, okay? All right, I also had another problem here. It's 3D review problem, which is in the Moodle page downloads. So we went over this in class a little bit too, had people working on this. There it is. So it's under the homework downloads, a little ways down. It's 3D review problem, okay? So you could download that and then go through it. Looks like this. So what we want to do is get that force and then with it find some things that are happening to that rod AB. So the first thing I wanted people to do was to find the force vector. So why don't you do that, and why don't you pause the recording before you do it and then start the recording up after you do it, and then I'll show you how to do that, okay? But do it on your own so that you get a chance to practice and learn a little bit on your own. Okay, so find that force vector from B to C. Okay, so why don't we go through how to find that force vector. There we go. So what we do, we find the vector from B to C. Now we reverse the order of the vectors and we subtract them. So to find RBC, we take RC minus RB. Okay, like that. And that gets us the position vector from B to C. Square root of sum of the squares gets you the length of the line. Divide that out and you get a unit vector from B to C. And then we can scale that up by the magnitude of 5200 and get a force vector from B to C. So there's the force vector right there. So that's a process. You should definitely know how to do that. Okay. Now the next thing we want to do is look at the tension and or compression in that rod from B to A there. So see what you can do to find that. We'll continue on with this one tomorrow. Okay, so we'll finish this tomorrow in class. And that's about it. That's about what we covered today in class.